there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and it's video 17 in the GCSE Maths Higher Revision section. I'm doing a video this time on scatter diagrams, just to remind you how to use these videos. Now, these videos are mainly for grade C and B topics at GCSE, the higher paper. So they're for students really working hard to try and achieve a C or a B. I'm not going to go through the topic in lots of depth. I'm going to show you the basic outline of the topic, and then you copy those down on revision cards, and then what you do is you try the exam questions at the end that are like that topic. So you pause the video, try it and see if you got the answer right in comparison to me. Right, so let's start off with scatter diagrams. What are scatter diagrams? Well, scatter diagrams are a way, basically a graph where you plot two variables against each other. So you plot two variables against each other, and you usually see an outcome of one of three ways. So say if they were you plot them on an XY axis as follows, and you usually see outcome of one of these three kinds. So you either see generally as you go up along the x-axis, you're going up along the y-axis, or you see as you're going up along the x-axis, you're coming down along the y-axis like that, or you see no discernible pattern, something like this, nothing where there's a pattern. Now, this first type is called a positive correlation, so you have to learn these words, a positive correlation. This second type is called a negative correlation. And this last type is called no correlation. Now, just to think what these graphs might be of, let's say this one here, it might be the hours you spend revising your maths and the score you get in a test. The longer you revise for your maths test, the better score you get in your test. What might be a negative correlation? Correlation might be something like the more time you play Xbox when you should be revising, what is your math score? So your math score tends to go down if you're spending all your time doing Xbox. And no correlation might be something like, I don't know, might be no correlation, for example, I don't know, the amount of time you spend revising on maths versus how good you are at riding a bike or something, how fast you are at riding a bike. There might be no correlation between those. So you have to know the words positive correlation, negative correlation and no correlation. And these are pictures of scatter diagrams. And there are four things they could ask you in the exam. So let's go through the four things they could ask you. The most simplest thing they could ask you is to describe the relationship between the variables, relationship between the variables. And that is where you would say the words positive correlation, negative correlation, or no correlation. Okay? You would use that there. So, for example, there's a positive correlation between the amount of time you spend revising and your math score. The second thing they can ask you is to plot a point onto the diagram. Now, just be super careful that you read your axes so you know exactly what each little square is going up in. So they've asked you to do that before. The next thing they could ask you is to draw a line of best fit. And I'll show you exactly how to do that in an example. And the last thing they might ask you is to estimate a value using your line of best fit. So when this question comes up, and it's come up every year, it's usually for 3 or 4 marks and they ask you a combination of these things. So I'm going to do an exam question. Here's the exam question here. So you can copy this down with me and we'll go through it, and I'll try and teach you all the various elements that we need to do. So this question says, the scatter diagram shows the information about the height and the weight of 9 students. Okay, so the height versus the weight of 9 students. So the height is along the x-axis and the weight is along the y-axis. Now, before you launch into the question, just think what everything's going up here. There are 5 squares here, and you go from 0 to 10, so each one must be worth 2. So on this side, put a little note to yourself that each little square is worth 2, like 2, 4, 6, 8, 10. It's very important you think about that. Now, what about going along this way? What's each one worth? Well, there are 10 squares here, and there is a difference of 10 between 110 and 120. So each one's worth 1 along here. So just take a moment to do that before you even look at the question. Right, what do they ask us in this question? They say the table shows the height and the weight of 3 more students. On a scatter graph, plot the information from a table. So what did I say? The first thing they could ask you to plot a point. So let's go back here. We have to plot 135 centimeters versus 70 kilograms. So go along here. 135 is here, exactly halfway, okay, versus, what do we say? 70. So looking up here, 70 is exactly here. So put a cross there, like that. Okay, the next one. 155 against 75. So go back up here. 150 and 5 against 75. Well, that was 70. So 75 is exactly halfway between 70 and 80. So it would be there. And the next one is 170 versus 85. So go back here. 170 versus 85, exactly halfway between 80 and 90 would be there. So we clearly got our 1 mark there, no problem. What type of correlation does this show? Remember I told you they can ask you to describe the correlation? Well, they have. What type of correlation does this show? Well, as the height goes up, the weight is going up. So there's a positive correlation. So you can just take positive correlation between, and state what is between, the height and weights of the 9 students. Or in 3 more now, so 12 students. Now, part C is for 2 marks, so it must be involved. It says the weight of another student is 80 kilograms. Estimate the height. Now, this is the key word here, estimate. Whenever you see this word here, it means 2 things. It's asking you in a hidden way to draw a line of best fit and read off that line. If you don't draw a line of best fit, you will not get the mark. So go back to our picture. Our line of best fit, here's a few that are wrong. That's wrong because it can't go past the first data item or the last. So that's the reason why that one's wrong. This one's wrong because it doesn't show that trend at all. Now some people might say this one's right. Have a look at this. Because you have roughly the same number above and below. That's not right because it's not showing a positive correlation. So what you've got to do with the line of best fit, here's your little tip. You need to do 2 things. You show the trend, i.e. if it's going up, and you want as many above and below, as many above and below and online as possible. So you want as many above and below, the same number above and below, and as many on the line as possible. So something like this is a good one. Let's have a look. You start off here, you'd start off somewhere in line with here. Now that's a decent one. Let's see why. Let's highlight why that's a good one. We've got 1 on the line, 2 on the line, roughly 3 on the line, and you've got 1, 2, 3, 4 below, and 1, 2, 3, 4, 5 above. That's a decent line of best fit, okay? So that's going to be my line of best fit, and I'm going to read off it. So 80 kilograms, so you want to go to 80 kilograms, and you must draw these lines. Find 80 kilograms. You're not allowed to just read off it without drawing a line. 80 kilograms there, and that marks it just about here, and you read down here, and it's about 164 centimeters. So you would write down there 164 centimetres is your approximate height? So that's a great question because it showed us all 4 things coming up. Remember, when you see estimate, you must draw your line of best fit first and read off it. Okay, now it's time for you. We've taken the notes down to have a go at some questions, okay? So on the website, I will give a pack for you to download, but here are the questions. Here's question 1. I'll go through it in 10 seconds. So, hope you've paused the video and had a go. This was obviously a positive correlation, so you would write positive correlation. Draw a line of best fit. My line of best fit would look something like this. Something roughly like that, but I'd adjust that now. Maybe something a bit more like this. I've got 1, 2, 3, 4, 5, 6, 7 below the line, 1, 2, 3, 4, 5, 6, 7 above the line, and 1 on the line. So that's a great line of best fit there for my next mark. Sarah's got a maths mark of, Sarah has not got her maths mark. Her art mark is 23. Use your line of best fit to estimate. Remember I said you had to draw the line of best fit for Sarah. So looking at the axes, these are going up in 1s, these are going along in 1s. So her art mark's 23, so we look at art mark and we go to 23, which is here. We must draw this line across, otherwise we don't get the mark. So draw that line across and we read down, and it looks like she would have got about 39 in maths. So we would write 39 as an estimate. And that's the first exam question done. Right, next exam question. Pause the video, try it. I'm going to go through in 10 seconds. Okay, this scatter graph shows the information about the height and arm length of each 8 students in year 11. What type of correlation is it? As the height goes up, the arm length goes up, so you state positive. And it says here, it says a different student in year 11 has a height of 148. Estimate the arm length. So that tells you must 1, draw a line of best fit, and 2, read off it. You must do that or you don't get the marks. So a line of best fit, let's draw that in, something like this. Okay, let's see if that's any good. 1 below, 2, 3, 4 below, and 1, 2, 3, 4 above. It looks perfect and it's going in the right direction. So we've got a height of 148, so you go to height here. Now be careful, you're going to this axis here. Let's just think what everything's going up in. There are 10 squares there, and each one must represent 1, and there are 10 squares there, so each represents 1. So a height of 148, draw a line up from 148, which would be about here. And remember, you don't get the mark unless you draw this, and reading across there, it looks like about 81, 2, and 3. So it'd be 83 centimetres for the arm length, 83 centimetres. And we're done. Okay, next question. If you haven't paused and done all the exam questions, pause now. I'm going to go through in 5 seconds, so pause. Okay, this question says the scatter graph shows the information about 10 apartments in the city. It shows the distance from the city centre and the monthly rent of each apartment. So the distance along here, the monthly rent. Let's check the scale. There are 10 squares and it's going up in 100. So each little square must be worth 10 along there. And there are 10 squares here, and each big square is worth 1. So each one must be worth 0.1. Because 0.1, 0.2, 0.3, 0.4, 0.5, etc. Okay? So it's important we have thought about that. The table shows the distance from the city centre and the monthly rent for 2 other apartments. On the scatter graph, plot them. So we've just got to plot these. So plot this, 2 with 250. So 2 distance with 250. 1, 2, 250, 100, 250 would be exactly here. And 3.1 and 190. So 1, 2, 3. Now 0.1 is just 1 square, and you're going up to 190. So 100, there's 200. Each little square is worth 10, we said, so it would be here. Okay, and we've got our mark there. Describe the relationship between the distance from the city centre and the monthly rent. Well, you can say there's a negative correlation between the distance from city centre and the rent. Okay? And lastly, an apartment is 2.8 kilometres from the city. Find an estimate, remember that word, tells us to draw a line of best fit and read off it for the rent. So firstly, draw our line of best fit. So something like this. Let's see if that's any good. We've got 1, 2, 3, 4, 5, 6, 7 below, and 1, 2, 3, 4, 5 above. Maybe it's not great here, so what we're going to do is just move it along like that. That looks a lot better. So we've got 1, 2 on, 1, 2, 3, 4, 5 above, and 1, 2, 3, 4, 5 below. Look, that's a way better one. 2 on the line, 5 above, 5 below. That looks perfect. So 2.8 kilometres from the city centre. So we go along this axis, 2.8. And we must draw our lines on. So there's 2. Each one's going up in 0.1. So we go to 2.8. And we read across. And it looks like £200 is our monthly rent. So we would state £200. Okay? Question 4, next one. If you haven't tried it already, pause now and try. I'll go through in 5 seconds. Hi, so the scatter graph shows some information about 8 cars. For each car it shows the size of the engine in litres and the distance in kilometres. So if we have a look at that scatter graph there, let's just think what the axes are. Each 10 squares goes up in 1, so each one here is worth 0.1. And now this is a bit tricky. 10 squares are worth 2, okay? So clearly you can see halfway between must be 7. So each square here is worth 0.2, because 0.2, 0.4, 0.6, 0.8 and 1. So you have to be super careful there. That's why this question is slightly harder. What type of correlation? Well, you can just clearly state negative correlation. A different car of the same size had 2.5 litres. Estimate, that means draw a line of best fit and read off it, the distance travelled on 1 litre of petrol by this car. Okay, so what we're going to do is we're going to draw a line of best fit. So line of best fit looks something like this. Is that a decent one? Actually, that's a terrible one. There's 2 above and there's 1, 2, 3, 4, 5 below. So not quite right there. Just change it a little bit. That looks a little bit better. So here we've got 1, 2, 3, 4 above and 1, 2 below. Still not quite right. Maybe just a little adjustment here. 1, 2, 3 above and sort of 1, 2 below. That's decent. Okay, something like that is kind of decent. Right? Right. Just change that a little bit actually. Still not quite happy with that. This way we've got, that's much better. Okay, so an engine of 2.5 litres. So we're going to get our engine size here. 2.5 is exactly here. And we draw a line up and read across, and that looks like it's 11, the distance of 11. So we would write that's 11 kilometres. Okay, next question. If you haven't tried it already, pause the video now, work through. I'll go through in 5 seconds. Okay, so here's the next one. The scatter diagram shows information about 10 cars of the same type and make. The graph shows the age and the value of the car. And so there it is. The table shows the age and value of 2 more. Plot these. So each 10 squares is worth 1 year. And going up here, 10 squares are worth 2,000. So each one going up, each little square must be worth 200, because that would be 1,000. 5 squares would be 1,000, so each little square must be 200. Okay, so all we've got to do is plot this. 1 against 8,200, 1 against 8,200, which would be 1 square up from 8,000, and 3.5 against 5,000. So 3.5 is here against 5,000, which would be exactly there. Very straightforward. And so, sorry, we've done that already. Describe the relationship. Well, it's a negative correlation between the age, and you should write this down, between the age and the value of the car, so you would have written that down there. And a car of the same type is 2.5 years old. Estimate the value. So estimate means draw a line of best fit. First, before you do anything, 1, 2, 3 below, 1, 2, 3 up, and loads on. That's a great line of best fit to start with. And 2.5 years old, so go to the age, go to 2.5, and read across like that. It looks like 6,000 and one little square, so 6,200. So 6,200 would be the value of the car. Okay, and last question in this set. Pause the video if you haven't done so already. Try this, I'll go through in 5 seconds. A publisher checks the documents for errors. He records the number of documents that are checked each day. He also records the number of errors. So we've got the number of documents checked and the number of errors. On another day, 90 documents are checked and 17 errors. Show this information. So 90 documents, go along documents to 90, which would be here, and you want 17 errors. Now, you've got to be super careful here. 10 squares, right, are worth 5. Okay, so, and you've got 20 squares are worth 10 here. So each 2 squares must be worth 1. 1, 2, 3, 4 and 5. So 2 squares are worth 1. So you want to get to 17. So it's not here. A lot of students would think it's there. That's 16. It's 17. You've got to read the scale. So 17 against 90 would be here. So be super careful there. That was a real trick with the scale. Describe the correlation, where you could just say that, you know, it's not a great correlation, but it's just about a positive correlation. You might even put a weak. On one day, 110 documents are checked. Estimate the number of errors. So, firstly, line of best fit, obviously. Line of best fit looks something like that. Now, is that decent? It's got 1 on the line. 1, 2, 3, 4, 5, 6 above. 1, 2, 3, 4, 5, 6. But actually, that's spot on. That's a decent effort there. And you want to, it's 110 documents. So you go to the documents. There's 100, there's 120. 110 is obviously exactly in the middle, which would be here, and then you just read across. So you read across like that, and it's about, so 2 squares are worth 1. You can't have 19.5. So I'd actually just say, just looking at that carefully, I'd actually say, you know, that's more like 20 errors. Just looking at that, so I would say 20 errors. And we're done for this video. Hope now you know exactly what to do to get all 4 marks in the scatter graphs question.